Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, question 8, 2019, paper 2 was a good question to do straight after we did the theory on confidence intervals and stuff and P values, because it focuses on that. So part A, a motoring magazine collected data on cars on a particular stretch of road. Certain details on 800 cars were recorded. The ages of the 800 cars were recorded. Okay, so ages. 174 of them were new. Find the 95% confidence interval for the proportion of new cars on the road. Give your answer correct to 4 significant figures. Okay, so if I go to my log tables, you can see, well, let's do our proportion first. Okay, so we can call it P hat if you wish. It's 174 over 800. So, or you can think of it as probability or proportion. 174 cars out of the 800 were new cars. Okay, so that's what we're dealing with. Now you're wondering, did you just get lucky that you had so many new cars in this group of 800? Did you perhaps get unlucky if you selected another 800 cars on that road the following day? Would you have much more new cars? Okay, so because you're not sure, because it was just a sample that you took, you need to create a confidence interval, or you need to add and subtract a standard error from your proportion. Okay, so it's that formula there. Sigma p is equal to the square root of p times 1 minus p over n. Okay, now we want to make it 95% confident. Okay, so what we're going to do is we're going to do p hat minus 1.96, because 1.96 is the z-score equivalent for 95%. So times p1 minus p over n is less than p, the population, is less than p hat plus 1.96 times p times 1 minus p over n. Okay, so your p hat is your 174 over 800. Let me get my calculator and just convert that to a decimal. For anybody who prefers decimal, so I've got 0.2175. So I want to minus off that. So let's work it out up here. It's the square root of 174 over 800 times 1 minus 174 over 800 over n. It was 800. Bigger square root sign. Put all that into your calculator. And it's square root, hit my fraction button, 174 over 800 times 1 minus 174 over 800, all over 800. Oh, I have 800. So it's a small amount, 0.014586. Okay, so it's 1.96 times that number, 0.014586. It's less than p is less than or equal to 0.2175, my sample data, plus 1.96 times my error. Okay, and when you do that, you should get, I just put it in red here under so you can see it, 0.1889 is less than p is less than 0.2461. Okay, or I could write that as 18.89% is less than p is less than 24.61%. Okay, and if I convert him to a decimal, you'd see it would be 21.75%, which is in the middle of your confidence interval. Okay, so that's your confidence interval, somewhere between 18.89% and 24.61% of all cars on that road are new cars. Okay, and you can say that now with confidence because you have the statistical data to back it up. So part 2, the data on the speeds of these 800 vehicles is normally distributed with an average speed of 87.3 kilometers per hour and a standard deviation of 12 kilometers per hour. What proportion of cars on this stretch of road would you expect to find traveling at over 95 kilometers per hour? Okay, so it's telling you it's normally distributed. Okay, so start thinking z-scores. If you see that, it may not always be that, but start thinking of that, and especially start thinking of that when they give you a mean, when they give you a standard deviation, and they give you a value to test. Okay, so 95 kilometers. What proportion is over 95 kilometers? Okay, so you can see when I look up z-score, when I create it, I'm going to get the big area, or I'm going to get the area less than that value. So I'll have to subtract it from 1 to get the little bit above 95. Okay, but the first thing I need to do is to look up a z-score. And how do I know that? Well, it's that word proportion of cars. So when you look inside the body of z-scores, you get proportion or probability of something happening depending on the context of the question. That will make sense. Okay, so that's where we're going. We're going to use our standardizing formula. Okay, x minus mu over sigma. Now, why is it not this one over root n? Okay, well, it's because I'm not dealing with means. It didn't say the mean data of the speeds. It just said the data of the speeds. Okay, so it's not mean of means here at all. It's not the central limit theorem. It's just straightforward z-score. So z is equal to the value that I'm testing, x. You compare it to the mean mu, and you see how many standard deviations is that equivalent to. So the value that I'm testing is 95. I'm comparing it to the mean, 87.3, and the step size, the standard deviation size is 12. Okay, put that into my calculator. So 95 minus 87.3 all over 12 gives me 0.6416. Okay, it's repetitive 6, so 6.7. Okay, so that's my z-score. Let's look that up and see what proportion is that equivalent to. Okay, so what did I say? It was 0.64, because I know it's only 2 decimal places I can look up. So 0.6, and there's my second place of decimal. So 0.7389. Do you see it there? 0.64. So 0.7389. Okay, so the probability that z is less than 0.64167 is equal to, I've forgotten already, 0.7389, 0.7389. Okay, like I said, that gives me the proportion of cars that's less than 95. How do I know that? Well, I know it from the log tables. So that's shaded in. So it's trying to tell you the values that you're going to get from this table is up to that score. In our question, we were asked for what's greater than 95. So therefore, it all adds up to 1. So if I go 1 minus 0.7389, 1 minus 0.7389, I get 0.2611 or 26.11%. Okay, so what proportion of cars on this stretch of road would you expect to be traveling at over 95 kilometers per hour? 26.11%. Okay, part 3. The driver of a car was told that 70% of all the speeds recorded were higher than his speed. Okay, find the speed at which this driver was recorded. give your answer correct to the nearest whole number. Okay, so when they give you a percentage, you're now inside the body of the table. They've kind of given you the answer and you're working backwards. Okay, so 70% is 0.7. Okay, so I'm going in here into the body of the table to see, can I find the closest value to 70%. Okay, so there's 0.70 there, so 0.53. That's 19 away from it. 85 is 15 away. So either 0.52 is closer, or of course you could go 0.525. You could kind of go halfway between them if you wish, okay? They don't really expect you to. They're kind of happy enough if you take the closest one to it. So that's 19 away, that's 15 away. So let's go 0.52. Okay, so therefore Z is equal to 0.52. Okay. So now they want the actual speed, okay? So you're working backwards, okay? So remember the standardizing formula that gave me that Z-score in the first place was X minus mu over standard deviation, okay? So it's that value there that I'm looking for. What speed gave me a Z-score of 0.52? Okay, so 0.52 is equal to X minus 87.3 over my standard deviation, which was 12. Okay, bring him up. I'm multiplying by 0.52. So 12 multiplied by 0.52 is 6.24 is equal to X bar minus 87.3. Bring him over and add him on. 87.3. And I get that speed being equal to 93.54 miles. Yeah. Okay. And then B part 1, a road safety program was carried out in the area using posters, signs and radio slots. After the program, the motoring magazine recorded the speeds of 100 passing cars. The magazine carried out a hypothesis test at the 5% level of significance to determine whether the average speed had changed. The p-value of the test was 0.024. What can the magazine conclude based on this p-value? Give a reason for your answer. Okay, so to answer this, okay, I would draw any normal distribution curve, okay, and I would color in the two pieces out here, which is 2.5% and 2.5%. So as a decimal, because they gave me decimal in the question, this is 0.025, 0.025. Okay, the p-value of the test was 0.024. Okay, so to conclude, the p-value is less than 0.05, so that's 5%. Okay, therefore it is significant. And therefore, remember what H0 would be, because it was a hypothesis test. H0 would be that the average speed had not changed. So because it is significant and we are out here in the outskirts, okay, we can conclude that the average speed has changed. Okay, so that's just looking at that piece of theory on what does the p-value mean, okay? the magazine found that the average speed of this sample was lower than the previously established speed of 87.3, so it was lower. Okay, find the average speed of the cars in the sample, correct to 1 decimal place. Okay, so let me draw that z-score again. Sorry, that normal distribution again. Okay, this is the significant area when you're talking about p-values. Okay, so any p-value is equal to the sum of the two shaded regions here. Okay, or I could say it was equal to twice the shaded area on the right. Now, why am I honing in on the one on the right? Okay, this one here, because when we look up z-scores, we only get the right-hand side, the positive 3 standard deviations, okay? But because it's symmetrical, the total area here and here is the exact same as twice this one, okay? And then how do I get the area of this one? Well, I have to go 1 minus, I'm just going to call him Z1 for no reason. 1, it's twice 1 minus the probability that Z is less than or equal to Z1. Okay, so to explain that, what I look up in the table is this Z1 score, okay, and I'll get this area. I have to subtract it from 1 to get this area, and then multiply it by 2 to get my p-value. Okay, so that's how you find p-values. Okay, so if you remember in this question, they gave us a p-value. It was 0.024. Okay, so here p is equal to 0.024. Okay, so I can say that's twice 1 minus p times z being less than or equal to that, what I just called z1. Okay, and you can call it anything, ZS for significant, anything you want, okay? ZP, anything you want. It's just a label. Okay, so now I need to solve this and I need to figure out basically, I need to figure out what this z-score is, okay? And then I need to work backwards here to figure out what was the speed. So once I figure out the z-score, I'll then figure out the speed. So I have the p-value and I'm working backwards now for the z-score. So that's where I'm going, okay? So let's solve this for this z1. So the first thing I'm going to do is divide across by 2 to get rid of that 2 on the right. So that's equal to what? 0.012 is equal to 1 minus the probability that we are less than that. Okay. Okay, let's subtract 1 from both sides. I get minus, what's that, 0.988. Let me just check that now. I did it in my head, 0.012 minus 1. Yeah, minus 0.988 is equal to minus p times z is being less than z1. Let's change the signs all the way across, and I'm just going to swap the sides so that it looks a little bit more normal. So what z-score gives me 0.988. Okay, let's pop into our tables. 0.988. 99, I'm gone too far, 97, 0.988 here. So what's that? 2.28 by the looks of things. 9887, oh, they're all 988. Okay, hold on, there's 988, there's a closer one. 2.26 by the looks of things. Okay, so Z is equal to 2.26. Okay, so that's the value that gives me that z-scores. Okay, right, the mean has shifted down. Okay, so because it's lower, I know it's the bottom half of the graph that I'm looking at, okay, because that's where it's shifted. So therefore Z is equal to minus 2.26, okay? So you always have to wonder, you can only ever look up the positive one, but you have to consider it could be the negative one. Okay, so let's insert a new page so we're not up on top of each other. So we've established that Z is equal to minus 2.26, okay? So just like we did here, we're now going to see, well, what X bar is that equivalent to? So Z is equal to X bar minus mu over sigma. Okay. Let me go back and have a look. Change the p-value was that. Okay. P-values is always done using the central limit theorem. So I'm just actually reading the question to make sure that I'm just checking to see, does it say means in it, or do you just have to know that the p-value was done using the central limit theorem? Yeah, you do. Okay, so you'll have to divide by root n, okay, because p-value comes with the central limit theorem. So therefore, my my minus 2.26 is equal to X bar minus, what was our mean? What was our mean? Oh geez, we have to go well back. 87.3 over and what was the sample size? 100 cars. Okay. So minus 2.26. Let me write that out just a little bit more clearly. Okay, so 12 over root 100. So I'm going to do minus 2.26 times 12 over root 100 is equal to X bar minus 87.3. And when it's on the lower side, you always expect a minus number here. You'll add this in and it'll pull this down because there's a minus number. So look out for the minus number on that side. So minus 2.26 multiply by 12 over root 100, which is 10. So I'm getting minus 2.712 is equal to X bar minus 87.3. Bring him over, so add on the 87.3. And I get that speed being equal to 84.588. 84.588. Find the average speed correct to one decimal place. So 84.6 kilometers per hour is the speed that they were going at, or that was the new average speed. So it had shifted down. Okay, so that's how the p-values work. That's how they tie it in together. So just an extra piece in it where you have to work backwards from the p-score to find the z-score, okay? And then once you have that z-score, it then becomes very similar to questions that came up already, okay? Such as that one there. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.